I know we did a lot of them in class. All right, number 7. And just a reminder, even if you haven't been here for some days, you still will take the quiz, and it's only announced because this is your first one. If it's something that you didn't understand or anything, that's why the safety net is there for the test to replace your quiz grades. If that's higher, so it gives you a chance. But otherwise, nobody'd ever be taking a quiz with attendance the way it is right now with everything. All right, we have 3x squared minus 13x minus 30 equals 0. Again, my equation must equal 0 before I start, right? Right, that's right. And so now everything's on the same side, it equals 0. I'm going to go ahead and factor. So multiply that first and last together. Negative 90x squared. Don't forget to multiply by the front. Because if you don't, you're not going to get the right factors here. So what multiplies to negative 90x squared but adds to negative 13x? Negative 18 and 5. So negative 18x and 5x. Always write your negative one first. It'll make your life a little bit easier as you go. So I have 3x squared minus 18x plus 5x minus 30 equals 0. Yes? Slash in half. What can you take out of the first two? 3x. What's left? X minus 6. The middle sign stays. How about the last two? What can you take out there? 5. And what's left? Good job. X minus 6 is the repeated factor there, so that's what I'm going to pull out. I have x minus 6 times 3x plus 5. They asked me in third block yesterday if you have to show every single step of solving here. And I'm okay. I do want you to show me that you set it equal to 0. If you can do that, the next part in your head without actually showing it, I'm okay with that. If you know that's negative 5/3 and positive 6, that's okay. Just be very careful because if you don't show that part, you're likely to get a sign wrong or more likely to get a sign wrong. So there are my two solutions. Does that make sense? Anything else from that homework sheet? 17. 17. 13. 15. Okay. I didn't think we did one like this yesterday, so I'm glad you asked. We did one like this in third block, but not in here. Let's see, 2x squared minus 9x minus 65 equals x squared minus x. So this one doesn't equal 0 to start with, so I need to make sure it equals 0. So my question is, which do I move and where and why? The stuff on the right side is moving to the left, right? Because why? You want to keep that very first one positive. That's exactly right. Good job. I want to keep the x squared positive. If I move the 2x over here, it would cause my x squared to be negative, so I want to keep it positive. So I'm going to move the x squared and, of course, the x as well. And you can do that all at one time. 2x squared minus x squared is x squared. Negative 9x plus x is negative 8x. I've got the minus 65, and it equals 0. Everybody good so far? Now factor. What multiplies to negative 65x squared but adds to negative 8? Oh, look at y'all. I didn't know that. Okay. Negative 13x and 5x. So I have x squared minus 13x plus 5x minus 65. Somebody asked yesterday what happens if you can't think of those factors, and I've had that happen to me before, and I would have my calculator and just be saying, okay, 65 divided by, maybe start with 2 and then go to 3 and then 4 and then 5 until you find the one that works. All right. What can I take out of the first two? X, what's left? That's right. Middle sign stays. What can I take out of the second two? 5. And what's left? I hope it's 13 since this one's x minus 13. And now my x minus 13 comes around to the front and leaves me with x plus 5. What do I do now? Set both of them to 0. So this one goes to 0, and this one goes to 0. Add 13, one answer, subtract 5, and there's another answer. All of the factoring and factoring and solving. So what the quizzes do is they always pick up where the other one left off. So the other one left off at graphing, so it'll pick up from that night's homework on. So no graphing on this one. We're graphing more today, though. Yay! But it's all the same thing. It's just factoring and solving. That's all that's on it. 5 questions, 3 factoring, 2 factoring, solving. Anything else? Okay. Intercept and vertex form. And if you recall, we went back and we took the ones that were in intercept and vertex form and we put them in standard form, right? We foiled them out and distributed them, got them in that standard form. But now we're going to talk about how it's convenient for us to be in this factored form and what all it does and what all it tells us, okay? And we're going to specifically relate this to graphing. Remember I told you the whole rest of the chapter is all about how to solve quadratic equations, and so one of those ways was to factor and solve. Another of those ways is what we're doing today, and that is to solve by graphing. And you may wonder why we didn't do this while we were doing graphing, but I thought that it was important to show you the factoring first so that you could relate the equation you were graphing to what the solutions are there. So I don't do guided notes very often, but these are pretty good little guided notes as a little bit of background. So we'll just run through these couple of things real quick, and we've touched on them already, but the solution to a quadratic equation are the points where the function intersects the x-axis, okay? So solutions, when we talk about quadratics, are the x-intercepts, are where it crosses the x-intercepts. Sometimes we call these roots, sometimes we call them zeros, and sometimes we call them solutions, but those are all synonyms to mean the exact same thing. So if I said, what are the zeros of the function? I'm really just asking you, what are the x-intercepts of the function? What are the roots of the function? Again, x-intercepts, and solution, x-intercepts. So those all mean the same thing. And so it's places where it crosses, of course, the x-axis. Oh, that was the next question, and I didn't see it. Well, there you go. So it's places where it's also referred to as intercepts, roots, or zeros. So any of those words be able to use interchangeably. Now, I can't remember if it was this class or third block, but we talked about it a little bit. We talked about the number of solutions. Now, how many solutions have you been getting when we solve these quadratic equations? When you factor and solve. Most time you got 2, right? There were a couple scenarios where you got 1, remember? So here's why that happens. If you think about it, if a solution is where it crosses the x-axis, okay, so let's think about a parabola. The solutions are occurring here and here, right? And when we found these algebraically, we set that equation equal to 0. Remember that? Well, that's because if you have this equation, anytime you plug a 0 in for y and you solve, you're finding what? Think about it in terms of a line. You put a 0 in for y and you solve for x, you found the what? X-intercept, right? If you put a 0 in for x and solve for y, you found the y-intercept. So it's the same concept, we're just doing it on a bigger scale here. So putting a 0 in for y and solving gives you the x-intercepts, which are also the solution. And this is why we're getting 2 solutions, because it's crossing the x-axis twice. But not always does it cross twice. In fact, I may be in a situation, so this is a situation where there's 2 solutions. It's crossing the x-axis twice, right? That's the very first scenario. I could also be in a scenario where what's happening here? There's only one solution because it's only touching the x-axis one time. What point is touching the x-axis? What's that called? The vertex. When the vertex sits on the x-axis, okay, that's a one solution scenario. You had a couple of those last night, and if you didn't figure it out, they were on there. But whenever you get something that looks like x plus 5 squared equals 0, and you had to solve it, well, that means x plus 5 times x plus 5 equals 0. You get negative 5 both times, right? That is where the vertex sits on the x-axis. That is a one solution. Can you think of a time when you have no solutions and what that might look like graphically? Anybody? Say that one more time. Okay, and that might occur sometimes. How about graphically, though? What does it look like? If it has no solutions, it has no x-intercept. Well, a parabola that goes on forever with no x-intercepts might look something like this. Do you agree? It's never, ever, ever going to jump down and touch the x-axis. It's going up. Yeah. So that's an example, or maybe it opens down this way and never touches. Either of those would be examples of a zero solution situation. Does that make sense to everybody? Yep, this is two solutions, one solution, this is no solution, and this is no solution. Okay, so quadratics can have no solutions, one solution, or two solutions. And when you graph it, if it has two solutions, it crosses in two places. If it has one solution, it crosses in one place. And if it has none, it never touches the x-axis. Okay, so we did a lot of graphing of quadratics, right? Say right, we did. Okay. The first one on your sheet, and this says find the solutions by graphing, okay? But I want you to add in those directions and by factoring, because I want you to see how they're the same thing, okay? So the first one is f of x equals x squared plus 2x minus 3. So the first thing I want to do is graph this. Do you agree? If I want to find the solutions by graphing, I need to graph it. What form is this equation in? Somebody can do this. Standard. That's right, standard form. So when it's in standard form, that's my worst form to graph in, right? I need to first find the vertex, opposite b, over 2 times a. Agree or disagree? Good. This is my axis of symmetry. But I need to find where on that axis my vertex is occurring. How do I find that? How do you find the other half of the vertex? Plug it in, right? So I'm going to say y equals, now this is f of x, but remember f of x is the same thing as y, it's just function notation. It's going to be negative 1 squared plus 2 times negative 1 minus 3. Looks like negative 6. Nope, negative 4, just kidding. Nothing new, right? Remember how I told you this all builds on itself? Instead of picking a point to plug in, I'm going to use my y-intercept as my easy point because it's pretty close to the vertex. So I'm going to go down to negative 3, and then what's my last step? That's right. So I'm going to reflect it over, and you've got a nice little graph that's numbered there that'll be easier for you to see exact points on. But go ahead and connect And what you're going to do to find the solutions here is you're going to say, okay, well, based on my graph, where does it look like my graph is crossing the x-axis? Okay, and that should be your two solutions. But you're not going to stop there because me and Miss McGee want you to do it algebraically also. Okay, so I want you to check your work and make sure, because I want you to make that connection. That's the biggest thing here, is that connection. That when you factor and solve, you're doing the same thing as when you graph and solve. So if I want to factor this or find the solutions, I'm going to say 0 equals x squared plus 2x minus 3. And now factor that. And y'all do that on your own. You should be able to do that. I'm going to be working it just for the sake of time. So you can look up and check what you got there. I hope as you factored that one down that you got x minus 1, x plus 3. And then, of course, if I solve it, because remember, I'm finding x-intercepts, which means I put a 0 in for y, you got 1 and negative 3. So those are your two solutions, but on your graph, when you look at the graph that you did, it should be crossing really close to negative 3 and 1. Okay, so you're just going back and double checking and making sure that those match up. Does that make sense what we're doing here? I will tell you on ones like number 2, if there's a negative in the beginning, factor negative 1 out as your GCF, okay, before you factor. So when you go to factor number 2, pull the negative 1 out and make it x squared plus 10x plus 25, and then factor that from there. Everybody know what we're doing? I know we're close on time, but you should be able to factor all those, and you should be able to come back and graph them. All right. That's all I got for you. I was going to show you how to do it on the calculator, but we're going to hold that off until Monday because it can get quite confusing. I'd rather not do too much today going into a long weekend.